Among all the moons in our solar system, one stands as the undisputed giant Ganymede. Bigger than even the planet Mercury, Ganymede is more than just large, it's magnetic. Welcome to Infinity Beyond, where today we unlock the mysteries of the solar system's largest moon and the only one known to have its own magnetic field. For decades, Ganymede was a quiet giant, its features veiled by distance and assumption. But in 1979, NASA's Voyager spacecraft delivered our first close-up glimpses. Then, in the late 1990s, the Galileo probe changed everything. Between these missions, scientists detected a surprising and drastic shift in Ganymede's magnetic field. That's important, because such a shift isn't possible unless something is generating the field from within, a fluid, conductive layer acting like a planetary dynamo. This discovery was the first solid evidence that Ganymede has a subsurface ocean, likely composed of salt water, buried beneath a thick crust of ice. What makes this even more intriguing is how Ganymede rotates. Its icy crust doesn't behave like a solid fixed shell. Instead, it rotates with a wobble, about 80 degrees, which suggests the outer ice is decoupled from the interior rock mantle. This mechanical independence implies the presence of a liquid layer in between. Imagine this. Ganymede has a metallic core like Earth, a rocky mantle, a global ocean possibly hundreds of kilometers deep, and then an icy crust. It's essentially a planet-like body trapped in moon form. The magnetic field of Ganymede doesn't just exist, it interacts with Jupiter's massive magnetosphere. This creates auroras at both of Ganymede's poles, visible in ultraviolet light. Hubble Space Telescope observations have even caught these auroral ovals shifting, supporting the theory of an ocean that influences the magnetic behavior. The presence of a magnetic field is significant. It means Ganymede has an active, differentiated internal structure, something once thought exclusive to planets, and it might help protect the moon's surface, or subsurface, from Jupiter's intense radiation. Even more fascinating, Ganymede might have multiple layers of ocean, sandwiched between high-pressure forms of ice. Under extreme pressure, water ice changes structure, forming exotic versions like Ice 6 or Ice 7. Some models suggest Ganymede's interior could contain stacked oceans, separated by dense ice layers. Ganymede's surface, too, tells a complex story. It's split between dark, older regions covered with impact craters, and lighter, younger areas crisscrossed with ridges and grooves, possibly caused by tectonic stretching of the ice shell. These terrains hint at a dynamic past, and perhaps even ongoing slow shifts today. Ganymede also has a tenuous atmosphere, composed mostly of oxygen, but it's far too thin to support life on the surface. If life exists here, it would have to be in the depths, beneath the ice, where the liquid water meets rock and heat may be generated from tidal flexing and core dynamics. The upcoming JUICE mission, Jupiter Icy Moons Explorer, from the European Space Agency will focus heavily on Ganymede. Slated for arrival in the 2030s, JUICE will become the first spacecraft ever to orbit a moon other than our own. It will carry radar instruments to probe beneath Ganymede's crust, magnetometers to map its field, and spectrometers to analyze surface composition. By studying Ganymede, scientists hope to better understand how ocean worlds form, how magnetic fields evolve, and whether this colossal moon could one day support life, or teach us how life may arise elsewhere. As our journey through the Jovian system continues here on Infinity Beyond, we realize Ganymede is not just a moon, it's a window into the complexity and potential of icy worlds. Next, we'll visit Callisto, the ancient and cratered moon of Jupiter. With its heavily scarred surface and possible underground ocean, it may hold secrets as old as the solar system itself.